Let's help you understand the starter test that we have given to you better. So under the test cluster over here, go to starter test. And then right away, you can see that it says inherits from test environments. So that means every feature that's defined in this particular superclass will be inherited to the starter test. Okay, so let's now open a new tab and go to that test environments over here. So this is a deferred class, and it's pretty much like an abstract class in Java, which means it's only partially implemented and cannot be instantiated directly at the runtime. Okay. So now the ones I want to talk about, you can see under the features panel over here, there are many things you should really explore by yourself. I'll just give you some idea. So the ones I want to talk about is under this section over here for setting up the environments for tree nodes, for testing the tree node. That's where you should start with for your developments. And I'll talk about environments empty and also environments int. So the int over here simply means every tree node we are creating for testing is going to store integer key and integer value. That's what we meant by the convention. Let's start with the environments empty over here, and let's try to visualize the test case. Okay, over here. Okay, let's now switch to iPad here. So now if you look at the test case, so these two lines are just about other variables which you will explore by yourself. Let me talk about these two. The first one will simply have a variable called root int. You can look up its declared type in the same class. And then we simply say make external. And visually speaking, we say that a square is going to be an external node. And a circle is going to be an internal node. Okay, this will be external nodes. This will be internal nodes. Okay, that's our convention. And then when we say make external over here, so that means root int is now going to store the address of some external node, which is a square. Okay, that's easy. And then also for testing purpose, as you will see later, we are also going to create a array list. You can think about array list is like a array implementation for a linked list, but it's like an array. And then we are using anchor type over here, which you learned from the Lab1 tutorial video. And then initially the maximum capacity will be 10, but the exact count, the exact size depends on how many elements you insert or force into it. We'll see. Okay, so now this is what we have got so far. And then you can think about the node over here, list, int, and int. It's simply just going to point to an empty array or empty list. Okay. Let's now see how we can build this up. So I want you to go to this particular feature over here. Command is called environments int. Okay, so that's what we should look at. And now it's actually pretty long, but the idea is very simple. Okay, we're trying to basically create individual nodes, and then we're trying to make them a tree, and then we try to also insert every node into the array list. That's basically what we're doing. Let me just go over with you very quickly. Eventually, this is the tree that we're going to create, and then we can also reuse this particular procedure of creating this tree for many other tests in the basic test. That's why I want to talk about this first. Okay, so we're going to create eventually 9 tree nodes. Okay, and then we simply just create every one of them. Okay, so like these 9 nodes over here. Okay, so for simplicity, I'm just going to include the key value, because key value is what matters for search. So you can think about we're simply creating a node for 1, a node for 2, node for 3, 4, 5, 6, 7, 8, and 9. So we're just creating nodes over here, right? I'm just omitting the value part, just the key part I'm showing. Okay, so now let's see exactly how these commands are supposed to be understood. So for example, when I say L2 is like a local node 2. Node 2 insert left, which means L1 should now become the left of L2. Okay, that's what it means. So L1 should become the left of L2. So now that's what we have over here. You can think about, so let's put L2 over here, and L1 is simply just going to become its left. Okay, that's what we can draw. Okay, and then let's go for the next one. So now L2.insert right is going to be L3. Okay. It's going to be L3 over here, so now it's going to be like this. Okay, hopefully you get an idea. And then we have another one, let's say L6 insert left, L5. So L5 is over here. Okay, and then we are trying to insert over here L6. L6.insert left L5. And then we also got L8.insert right L9. Okay, it's like that. Okay, you just have to continue with this particular process over here. Okay, and then we have to say L7.insert left L6. So that means we're going to go over here and then let L6 be the left child over here, right? Okay, it's, we're almost done. And then L7.insert right L8. Okay, so that means it's going to be insert right. It's going to be L8. So let's move it over here like that. Okay, and then let's go on to see L4.insert left L2. L4.insert left L2. Insert left L2. So now we can simply move this guy over here to here. Okay, we got one final thing to connect the whole tree. So it's going to be L4.insert right L7. Okay, so what I will do is L4 is exactly over here, and then insert right L7. Okay, so now let me just move this a little bit up over here. And then L7 is exactly here. Okay, let me just adjust this a little bit. Okay, so that's the tree. So you can confirm that this tree is exactly what's really drawn in the command in the comments over here. Okay, so now what we want to continue with is how we can create this particular list. This one is very straightforward. So you're simply just going to insert. Remember we talked about fours previously. We're going to insert one by one. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, like that. So what we will do. And one line I forgot to show you. And then we say root int will be exactly L4. So what we are saying is, so now the root over here, rather than pointing to here, it's now actually going to point to this particular root. So you can think about this one tree node, and it's the root of the tree. It's connected nodes, basically. And then we're going to simply insert node 1, 2, 3, 4 in this particular sequence. So node 1 is over here. Okay, it's going to be inserted exactly over here. So we talk about aliasing. Okay, I'll mention that in just one moment. So the first element over here is going to be just 1. However, you should really know that this node over here, 1, and this node here, they are the same objects. So just make sure one thing to mention one thing. So you can think about over here, this particular node. If you try to compare that with node list int at position 1. If you try to use a reference comparison, so that should be simply just true. Okay, just that you understand. Okay, we're going to continue with this, and then we're simply just going to say, for example, this will be number 2, the 2 node, and that will simply just be the same reference as node 2 over here. Okay, so you will just keep going, and then you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. And later on, when I explain some specific test cases for tree node, I'm going to assume you understand how these things are being set up. Okay, so that's a very short demonstration about how you can understand the general setup for the tree node tests, and then you can move on.